So hello guys, welcome back. Now we are going to start the development process. As usual, we are going to create a GitHub, a Git repository where we are going to store our source code. Okay? So with the Git repository, so let's create a Git repository for our project. So let's create a new name, battery rule, remaining useful life. So my repository will be public. So I'll add a README file. Then for the git ignore, it will be using Python as a programming language. Then for the license, you can use any. I'll use MIT license. So that's all about that. So we have a repository name. We have ensured that our repository will be public. Then I'm going to add a README file, a git ignore as well as the license. Okay, so that's okay. So after that, you can now create a repository. So after creating our repository, we need then to clone this repository to a folder in our local machine or in a local desktop. So I'm going to open an Anaconda prompt. So Anaconda prompt, I'm going to open this. Then we need to clone this. So see, I'll use this. So the first thing that you need to create a folder. So I've created a folder in my local machine. So battery rule spread. So it's something battery remaining useful life prediction. So I'm going to copy. Let me just delete this folder. Let me just copy this file path. Okay. So folder path to that folder. So cd, then I'll just paste the folder name itself, the path, then e. Then we can use the command git clone. So git clone, then you can copy the code from this place. So you can just click on this button, then copy this link, and go back to your Anaconda prompt, command prompt. Then you can just paste your link. Then after that, click enter. Then you'll be cloning the battery rule Git repository to your local machine. So after that, you can see that we do have the battery rule folder created in the desktop. Then we have the git ignore, the license, as well as the README file. So we have created a folder and we have cloned that repository to our local machine. Then after that, so I'll just clear this. Then we can open a VS Code. So I can just open the CMD command prompt. Then to open an instance of the VS Code, so I'll just use the command code space dot. Then this one will open an instance of VS Code. So then in the VS Code, I'm just going to go to the folder. So I'll open that folder that we have created. So folder MLOps projects, so battery rule. So we open this folder now into our Git, so this is the folder itself. Okay. So that's the authors. So that's it. So for this one, I can just clear this one, then close this tab. Also, another thing. Okay, that's okay. So this is our Git repository. I'll make sure to also provide a link to this Git repository. So after that, we need to create the necessary files that we do require for our project. So earlier on, so we can create a new file and name this file template.py. So the template.py will contain the necessary files and folders that we do need in our project. Okay, so I had already prepared that, so I'm just going to paste that script here. So you can see we are creating a new, we are creating, so these are the necessary files as well as the folders that we do require in our project. You can see we have the components, we have the utility, the pipelines, the entities, and all that. We have the schema, app.py, the setup, we require that, the requirements, the .txt, where we list all the dependencies that our model will require, the experimentation, where we'll be testing the different components to see if they are working before we convert that to modular coding. So this script is, with this script, you are able to now create all these files and folders for your project. The conventional way is you'll be creating one file after the other. So, but that is a strenuous process, laborious process. So you can just create a template like this. Then you might be updating or removing some of these files if you don't necessarily need them. But all in all, we can use this for a start. But before we execute this, we need to do one thing. We need to create a virtual environment before we can progress, or even before we execute this template.py file. So let me create a virtual environment. So I'll open the command prompt. So so this is the command prompt. So I'm going to create a new Python package name, no problem. So we can create a new environment. So I'm going to create a Python environment. So for creating an environment, I'll be using the command conda create minus -p venv. So venv conda create my -p venv. Then I specify the Python version. So I'll use the 3.11. Then some notation so that if we are asked, you just pick that. If you ask that you need to create this, you just pick with this -y. So conda create -p venv Python 3.11, that one. So that's okay. So when you press enter, you're going to create a new virtual environment that we are going to run our project on. Okay, so this will take some time to create the environment, and after this is complete, we can then execute the template.py to create those project files as well as the folders, the necessary folders. Okay, so you can see creating our environment. So downloading selecting the packages. So these are some of the packages that our environment will come with the environment itself. So after we have created our environment, then we need to activate our environment. So this process will take some time. So let's just be a little bit patient with it. So just a quick overview of the template.py. So you can see we are creating a package name for this. So the src folder it will be a source folder. This is where all the code will be running from. So the src folder will contain all the configurations, all the entity, the components for the model. So all that will be contained under the src folder. As you can see under the components. So remember, in a machine learning model, we have the different components: the data ingestion, validation, transformation, So you have the model trainer, the model evaluation, and so on and so forth. So we can also include here another one, which is the model evaluation. You can also add another one, let's say model after evaluation, you can go to model validation. See, can also do model validation. Validation, something like that. Okay. So we have the model validation, the utils. So utils will just contain the necessary or the reusable functions. So all those functions will be stored under the commons.py file. These functions include, for example, the reading of the different YAML files. As you can see, we have different YAML files. So the function to read those files, all those functions will be contained in the commons.py. So under this, we'll just be importing those functions into the different components, and it will enable us to read the YAML files. If you have a TXT file, you can create a function for that. If you have a JSON file, you can create a function for that. So whenever we call that function, it will be reading those files from different locations. We also have the configuration. Then we also have the pipelines. So remember, we'll be having different pipelines in our model. For example, the data ingestion pipeline, the data validation pipeline, the data transformation pipeline, model evaluation pipeline. All those pipelines will be necessary in our project. We also have the entity configuration entity. We also have the constants file. So constants file, these are the common entities in our folder. So the constants mostly will be paired with the configuration. Then we have the exception file that will create a script that will enable us to raise errors in our code. So for the logger, then that is for the logging purposes. So for the different steps, you need to be logging those steps so that you are able to query your code itself. So we have the config.yaml file. This one, I think by this we'll just be specifying the file path and all that. The params.yaml, this will contain the parameters for the machine learning algorithm that we are going to be using. We also have the schema. Schema will contain information about the columns that are in our data. The main.py will be a central place where we can execute all the pipelines. So from the main.py, you can execute the entire pipeline so that we are able to do the data ingestion all the way until the prediction. Then we have the app.py. So if you want to develop a front end where the end user will be able to interact with the model, then we have this. So for this, we'll be using the Fast API, Flask. We'll create a Flask app, which is just a sort of a web application, which the user will be interacting with the model. We also have the setup.py, the Streamlit app. This also another application we can create for this model. We have the requirements.txt, requirements dev.txt. So for the requirements.txt, this will contain a list of the dependencies that we do require. So when you are trying to do something like the PyTest, things modular testing, I can't fathom that word. The PyTest or something, I'm forgetting that word. So this one will contain the requirements for doing, I'm forgetting that word, sorry. So for the experiment, we'll be experimenting first. So we create a script for data ingestion. For example, we can create the entire code for data ingestion before we split the code into the respective parts, just to see if experiment to see if it will be working appropriately. Then so that will be all about the experimentation. So we'll experiment the different components to see if they are working appropriately. Then from there, we convert that into modular coding. So we also have, after that, since we are going to create a web application, so we have the different HTML files. So the home, the index, the prediction, as well as the training. So this will be handling the different types of requests here. Okay, so that's it. So for this, you can use now this. You can just loop through each file in the list, then split the file path into directory and the file name, then create the directories if they don't exist, and create an empty file if it doesn't exist or if it is empty. So this is just a script to now execute and create all these files and folders. So while we are discussing that, you can see that we finished creating our environment. The next thing is all about activating this environment. So I can just copy this command, then paste. So conda activate this, or you can just use the command conda activate venv with a slash. Then from there we can just activate your environment. Then from there we can start the project itself. So the main goal is all about creating the template.py. So with this, you're able to create these files, then you create an environment, then we can execute, or after activating it, then we can run this command to execute the template.py to create the necessary files and folders. Okay? So this one, as you see, this is very easy. Instead of creating a file or a folder step by one by one. Okay, so this is just a shortcut for that. Okay, so you can see now we have activated our environment. So after activating our environment, we can just save this template.py. Then we can now run that. So Python template.py. So template.py. So Python template.py. So when you execute this, you will see that now you can see we have created the necessary files. So there's a problem here. Requirements dev, we need to include a comma. So requirements dev.txt, you need to include a comma here so that it's not considered as a folder. So what we can do, let's delete this and then execute this afresh. So Python template.py, make sure you have saved. So execute this again. You can see we now have the requirements.txt file and the requirements dev.txt. So after we have created our files, the necessary files and folders, so let's push this to our Git repository. So I'll start by there's something that under the git ignore, in our project we do have an artifacts folder. The artifacts folder, so let's just create the artifact. We'll create an artifact folder, and this artifacts folder, you'll see the usefulness of this artifacts folder, and that folder will contain the metadata and the different the metadata and something to do with the data itself. When we query the database itself, we'll import data into a model. So for example, we don't want to push that data to our Git repository. Also, if we split our data into the training set and the testing set, then we don't need to push all those artifacts to our Git repository. So we'll create an artifacts folder and make sure that folder, we don't commit that folder to our Git repository. So I'm going to make sure we avoid that. So in the artifacts folder, so artifacts slash. That means any file under the artifacts folder won't be pushed to the Git repository. So I'm going to save that. Then after that, we do a git add. So git add dots. So this will add all the folders and the files. So git status, this one will see which files we are committing. So as you can see, these are the files we are committing, the git ignore. Also the virtual environment that we created, we are not again pushing that to our Git repository. Okay, so those are the things that we are going to be ignoring. And for us to ignore that, we need to specify in the git ignore file. So for example, the venv, this, we're not going to push that to our Git repository. So whatever file we are defining in the git ignore won't be pushed to the Git repository. So after this, we do a git commit. So git commit minus -m. So we can say project files and folders. So we can do a project files and folders git commit. Then this one we are just staging. So after this, we can now do a git push. So git push minus git push -u, origin main. So when we do the git push, now we can go to our Git repository after this is terminated successfully. So we can go to our Git repository. Then we can reload this again. And from here, you can now see the different files and folders that we have created for the model itself. Okay, so this the files and the folders. So you can see now we are able to clone our Git repository to the VS Code itself through the folder that we created in our local machine. So that's it. So I'm going to clear this. Yes. So after that, then the first step is all about the requirements.txt. So we create a list of the requirements that are necessary for our project. So let me copy those files in the requirements.txt. So essentially, these files include the pandas, the scikit-learn library, the numpy, the matplotlib. We are going to create a web application, so we need the Flask IPY kernel, because we might use, in the experiment, we might use the Jupyter notebook, and we need the IPY kernel library installed in our environment. We also need the XGBoost. That's the algorithm that we are going to be using. The Python box, we are using the config box. It will be used for, if I'm not wrong, in terms of erasing error. Then we can use the Python box. The PyYAML, it will be used for reading the YAML files. Ensure this is a library that enables us to, I think I'm forgetting what. So if we search, let's say Python ensure, ensure is a set of simple assertion. So set of simple assertion help us that let you write more extensive. There's a specific function with the ensure. I'm forgetting whatever. Anyway, we can just search for it. Joblib, then Flaxcos, the Joblib, the Seaborn, the PyMongo, because we'll be querying data from a MongoDB database. Then Streamlit, because we are also going to create a Streamlit application. So in terms of experiment tracking, model registry, we'll be using MLflow. You can also include DVC for data versioning. Okay, so these are the necessary requirements that we do need in our project. So to ensure that we install these requirements, let's first create the setup. So for the requirements, you need to add the e dot, so hyphen e dot. Then for the requirements.txt, so for the setup, so we need to create our setup. For my case, this is my setup. So we are importing these setup tools, then list, and the hyphen e dot, remember, it's just this requirement. So that's the hyphen e dot. So we are going to create a function, the get requirements from certain file. So this file will be the requirements.txt file. Okay. So the requirements get a list, then with open file path. So we are opening that file in the requirements.txt file, then reading the information in that file, okay, and storing that information in terms of a list, okay. Then also included in our setup, these are some of the metadata for our project. So in terms of the version itself, the repository that you're going to call the model, okay. So for example, the name, the version, the license that we are using, the URL for that, then a description for the project. So this is a project to predict the battery remaining useful life in a battery. The author name, so this is just my name. Author email, that's the email. The packages, so find packages, and then for the install requires, so this is the function that we created, and it's going to read data from the requirements.txt file, and this data in the requirements.txt file. So this is the data itself. So for us to import these files and folders, so I'm going to save the setup.py, so the requirements.txt, again, I'm going to save this. So after this, the next thing we're going to install this. To install these requirements, we need to run a command. So the command will be pip install -r requirements requirements.txt. So pip install requirements.txt. So it will find this file and it will install all these dependencies. Okay. -e dot ensures that this is considered as forgetting. If you go back to my previous the previous project that we did about electricity bill prediction, you can find more information about this, about the -e dot, why we are using this. Okay, I'll also make sure to provide a link where I've tried to explain the usefulness of the different files and folders in this project. Okay? So pip install -r requirements.txt. So we'll execute this command and it will download and install all these packages in our folder. So as this is continuing, then we can also, because it's going to take some time, so we can do other things instead. I don't know why it's saying this. This is how you can install the requirement. So it will download and install. So I did the same so that we can just save on time, because this process takes quite some time. So after this, now we are at the requirements.txt. The next thing is we can start now with the data ingestion part. because this is continuing to download and install all those. So let's start with the data ingestion component. Before we start with that, we need to ensure that we can create our logger. We can create the constants, so those common stuff. So let's start with our logger. So let's create our logger. So for the logger, I want to use a file logger under the battery rule. Under this folder, we can use the init, so that we just, instead of importing as a file, we can just create our logger in the init file itself. So let's create our logger. So import login, then import OS library. You can also import sys. You can also import date and time. So from date time, let's import sys from date time. Going to import date time. Then I had already prepared this. So what we can do, just paste this here. Then can define the log file name using the current date and time. So month, day, year, the hour, minute, and the second. So we are creating a logs file. Okay. Then create the path to the log file. So this is the path to the log file. Then create the log directory if it doesn't exist. Then this is all about the logger configuration. So format, so that's the handler. So for the handler, it will print two separate information. So one information will be in the logs file, this one here, and another one, it will be in our terminal or console. So that's why we are preferring to at least create two logging where we can get our logger information. So this is the logger information that we'll be using. So this will take quite some time. So this is all about the logger. So when we execute this, you can see how we can work with that. So another thing is about the constants. So for the constants, again, let's already prepared that. So this is all about the different paths. So the config path. So config path will contain the different paths to different artifacts. So these artifacts include the data, also the training data, the testing data, and all that. So the params.yaml, this will contain the parameters that our model will be using. Schema is all about the data, the column names, and the target column. The metrics threshold will be all about a model validation. When we will be validating our model, we want the results to be in a specific range. Okay, so that's why we have this. So So this is done. So this is all about the constants. Then we have created the logger. You can also create the exception. So with the exception, this will be about how we can, so we are creating a script to help us raise errors in our code itself. So this one is a custom made error custom made script that will enable us to raise errors in our code. So this one is custom made, but when you go to our requirements.txt, for example, the Python box, the Python box, this one is you can call it an inbuilt function that you can use to raise errors. But for the exception, this one is custom made. So we make this so that it can suit our needs. Okay, so this is about the exception. So after this is done, what we can do with this, so I think this is quite a lot of taking some time, but I think it's done. So we can whatever we have done, we can push this to a Git repository. So we created the constant, the logger, then the exception. So we can just push this to our Git repository. So what we can do again, can do a git add dot git status. So for the git status, you can see the files we are modified, the requirements.txt, setup.py, then the constants, and as well as the exception. Okay, so we are going to, there is something that I did not save this. So we need to make sure you have saved before committing. Exception, that's okay. For the constants, make sure you have saved this. For the logger, make sure you save. I don't need this one. Data ingestion, not at the moment. We need to add that for the logger. So I'm going to do a git add again, just to make sure we have added the files that we have modified. So status, the git status. Yeah, now you can see that this one I think was for the while setting up the logger. Constants exception is for the exception. Setup.py, yes. Then the requirements.txt. So that's okay. So after this, we can do a git push, git commit, -m. So here you can just say setting up constants. Then can do a git commit that. Then at last we can do a git push. So git push -u origin main. Git push -u origin main. So after this, and push this to our Git repository. So I'll make sure to provide a link to the Git so that you can also follow through on your side, and probably any other link that will be necessary for this project. I'll make sure to be leaving those behind so that you find it easier to be working on the same project while on your side. Okay? So I'm just going to push this. then I think we'll end the session at this point. Then the next step, what we'll be doing will be creating the commons. So as I had said, these are the common functions. So those common functions will be creating under the commons .py file. Then after that, we can start now with the development process. So with the data ingestion, data validation, all the way until model validation. Okay, so those will come as in the new the upcoming session. So let's see if we have committed this. So what the comment was about yeah. So I think we have that is okay. So that's okay. So right, so that's it. So we are going to end the session now at this point. So you can also do the same. Make sure when we get started with the different components, make sure you have created it as your environment. You have installed the necessary requirements, and I think by that you'll be ready to now start, ready to go, because it will be quite engaging. So you won't need to be left behind. Okay, make sure you have everything installed before we get started with the data ingestion. Okay, so that's it. Once again, thank you for your time. Please remember to subscribe to the channel, hit that notification bell so that you never miss any of these updates. You can also share with friends, comment, and also like this video. Thank you for your time. See you in the next one.